for the electronic music and media art study program on the Faculty of Art. And also I'm running the makerspace, which is a very, very small, maybe daughter of Media Lab Prado in Pécs. Maker is a privately run kind of makerspace, so a technological lab. And yes, sorry, a moment. Okay, so I'm going to present Makkeróni, which is a web-based kind of operating system, which is a bit in parentheses. So it's a simulation of an operating system. It is a long time of inspiration in my work. And the first what I found to start me to make a sonic operating system is a sonic finder of William Gaver. This is. Maybe you heard about it, or maybe heard it. It was in the end of 80s when he proposed to make an operating system where the processes and the tasks has the own sounds. It not only so it is not only the sound of for example beep sound like this volume changing, but also a deep approach to reflect the work of the system. He also figured out the concept of auditory icons. Maybe you heard this name. This is a non-visual but auditory icon topic. Anyway, it was lost in the history, so nobody needed an operating system like this because sounds on this system are mainly disturbing and not useful, and also the sounds which presents the sound, the processes, they are unnecessary to represent in sound for the current I don't know computer world. So the next one, what I found as an inspiration, it was a work of me in 2005, which I tried to apply for the Linux Audio Developers Conference. They does not agree with this work. It was a concept for make the system pros, so the pros folder of Linux audible. So the kind of processes like file copying or just simply idle process with some disturbances. I just transformed the pros folder, so the inside of the data transfers to sound. It's very, very loud, so I can agree why they don't accept this, but so maybe for after lunch it's good to listen one of them. So I show the second one, or maybe the first. Sorry, this is better. If it plays, I don't know. Probably we have luck and does not start. No. Sorry. Okay, so I started from here. So the picture looks like this. So this is the sound wave, and this is the sound. I try to be quiet. So that's what you heard. I made on a Debian, maybe Debian Linux system, by simply pipe the pros folder to the DAC. Okay, the next inspiration was, of course, the working web audio live coding environments, what you know all, so Gibber by Charlie Roberts, and Slang also. And the fourth inspiration for me was the Bash itself, because I like this type of minimalism and the bit laziness what Bash, so this terminal shell, produces. Maybe I will skip the previous works. I just show only one, which is Moji OS. This is the first what I try to implement an operating system like Ding into the browser. That's I made for a student of us in Pécs, who, so for a Santa Claus gift or something else. He was very open for post-structuralism, and therefore I just made a post as a deconstructivist text player. Does not have sound. Wow. Okay. Anyway, it has not only text, but it has sounds. Yeah. Okay. I close it, and now I'm going to present the concept of Makkeróni. So I hope that you see it. Yes. Okay. Maybe it can be seen. So the first was to make an environment which is very so not stupid friendly, but lazy friendly. So you can leave the arguments free for up to the computer to decide. I also let the system to use different structures that live coding use. So I don't feel that I make codes, but I'm sending comments to the system. But I try to use the benefits of live coding, like autocomplete, auto-argumenting, and command line history. The fourth part of the concept was like in the audio finder, the sonic finder, that to make an operating system-like interface where the sounds which are naturally part of the working and the intended sounds, so what you synthesize, are together, so on the same channel. The next was to make a system which makes easy to learn a Linux shell to use, and also I like to make web works which is not only running in a browser, but they try to use the natural capabilities for peer-to-peer communicating among the users of the website. And also try to find the ways for low-level manipulate the sounds. So like what you heard with this Linux pros file system sonification. Okay, maybe I try to skip this because I will show how they work. Just to the next part, I realized this type terminal with the Jquery Terminal. This is what is it? Okay, so Jquery Terminal is a JavaScript application for creating terminals on websites. Sorry. It can be used and learned on this website. Also, I use web audio, so the recommendation of or the standard for HTML5, and I use for network communication Node.js and Socket.io. So I try to start the system, which is running here. If you load it, so which means that if you open the website, then you see this. If you have laptops, then you can also open it's I try to make it bigger. Yes, so the website is Makkeróni. Yeah, it makes sounds. If you type a sound, if you type a command which has no sense, then it makes some random sounds. So if you want to join, just open the website. And okay, so this terminal shows the prompt where you can see which user you are. Your computer gives a user number for you. The most basic Unix command is ls, which makes a list of the files in the system. Currently, we have a recursive listing process where we can see the text files, the presets, and the sound files which somebody uploaded. It's easy to upload sound files, and everybody can use it after you upload it, just by simply loading it. If you want to load a file to play, just simply use play and choose some of them. Please choose something if you want. Which to play? It's the check that you can see the types. Sorry? To one. This? This? Sorry, I didn't heard. Sorry, this is a... it's this. If you don't hear it, just play it one more. It's nothing. Oh, yes, it's here. They are not too dance floor friendly samples anyway. If you don't use arguments, then the system will add something. So in this case, the file is this. The rate to playback is this. If you want to change it, just simply use a different number, for example, 3. Now it's a bit quicker. Yeah, it's hard to see. Maybe I open the... Oh, okay. And also you can change the velocity for a different one and depending also. Or if you want to just simply trust the computer, then you can add random numbers, which is the asterisk. Okay. The situation is the same with the loop play. So if you, for example, loop plays cards 1.wav, then it plays it looped or not. It's every time a surprise that it works or not. It works. Okay, as you see, if you start a thread, then you can stop it by clicking on the stop 1, stop 2, etc. Or just simply type stop 1, stop and stop 2. Yes. Okay. It's also possible to synthesize sounds, of course, because Web Audio is making it very, very easy. If you type FREC, it produces a sine wave, which is also a random sine wave. You can start a lot of random sine waves by just simply starting it. Or also you can start random sounds by simply use the batch command. For example, batch with the argument 3 starts 3 of them. 2 minutes? What? Okay, I don't want to be so slow. Sorry. FM-FREC makes FM modulated frequencies, and Makkeróni is a very strange object. I try to make it quiet because it makes a mathematical operator on the signal, so therefore it looks like this. Yes. So it can make also divide on a frame level. Okay, just for the last 1 minute, if you want to communicate with other users on this website, then you have to connect to the chat server. And if somebody else also connects, for example now, thanks, then you can send commands to them also. So for example, if you say val minus min 0 minus max 1000 and frec, then it makes sounds on different computers. Maybe, I hope. The min and max is useful for limiting the user range. So if you, for example, in this case, yes, also if somebody sends, it's great, thanks. So for example, if you want to send comments for the range 0 and 500, then you can use simply 0 and 500, and then you can hear it only on this part of the room. So it's good for distributing commands and also a bit synchronizing the cooperative job. Okay, so maybe that's over. Thank you very much. And I forgot to say in the beginning that thank you for let me talk about this, because it's not strictly about live coding, it's more about live commanding or something else. And also thanks for the organizers to organize this event, which is really respectful. So thanks for the attention.
All right, we have time for a couple of questions. I'm going to ask that we focus on questions and not comments. I think there's a lot of people with opinions in this room, which is awesome. But let's actually dive into what people are presenting. Thanks.
Hi, I was just, you mentioned that it's not specifically live coding, but it seems very live coding to me. I was just imagining, can you talk about how you would imagine it being used in a performance setting? Or have you used it in live performances yet?
Oh, yes, so the general aim was to make a live performance interface for me, which I can use easily. I also tried a lot with Jquery and also with others, but for me it was more handful, because I just type the command and type enter, so it's more expressive for me, and also these hacks of the hack of web audio is very good to create very interesting digital sounds, which I like. Anyway, I also use mixing and the null input mixing and effects on this. So I don't use it alone, but with others too. But yes, so it was intended to live performance, of course. Cool. I also used it in page, so where I live, for making music, or not music, with it with people who played drums and synthesizers. Yeah.
Nice. It's really interesting work. Thanks.
Thank you. Thank you very much. Anyway, it's a strange thing that nobody in page uses Makkeróni, but everybody uses Jquery. So and they make very good sounds with that environment. But I forgot to say that it's interesting to make applications for the web, because so you can use it on your phone, or you can use it on different computers. You don't need to install or simply support it, because you can perform updates in a minute. Yes. So this is the live performance on the end. Yes. Thank you.
Is our next presenter here? Yeah. Go ahead.
¿Se agarra? Okay.
15 minutes? No funciona. ¿Puedes volver a sacarlo? Okay. Oh, no, it's fine. 15 minutes is fine.
¿No?
Ya, pues ahora los abro cuando esté lo más cerca posible.
Sí.
Sí, sí.
Este...
Ese no funciona. Espera, déjame entrar el mango. ¿Qué pasó?
No hay diapositivas. Pero sí está conectado.
Ya, o sea, sí lo vio. Entonces es como... esto. Solo funciona mejor si lo apagas, se lo da y lo enciendes.
Uf, pero es que tarda como 10 minutos. Sí. Esto está bien.
Detectar alguna señal.
No, no tengo.
¿Tienes entrada VGA?
No.
No, no tienes
No
entrada
tengo.
VGA en la computadora. ¿Thunderbolt tienes?
Creo que sí.
Sí, Thunderbolt.
Sí.
Pues puedo empezar, realmente las diapositivas. ¿Quieres que abra un micro? Pues puedo. Bueno, no. Vamos esperamos a ver si el Thunderbolt.
Bueno, la salida sería esta.
¿Tienes el VGA? Si quieres. Subiendo el micro. Pero ahora los ojos todavía no están. Va que va.
¿Dónde lo conecto?
Thunderbolt.
¿No?
¿No? Sí, por favor. Sí, sí. Probando, probando. Hola. Hi, everybody. Well, first of all, thanks for the organizers of the ICLC. Thanks for Media Lab, El Prado, and thanks for everybody for being here and listening to us. This is quite exciting, and well, let's keep going. So we're presenting here a small piece of software that we call Nanc-in-a-Can Canon Generator, and it is a series of classes and methods that we designed for SuperCollider, so we can produce temporal canons as the ones proposed by the composer Colin Nancarrow. Is anybody familiarized with Colin Nancarrow, his work or something? Oh, well, that's a lot, actually, like 5. That's more than many times. Well, okay, he's a composer that composed a lot of rhythmic music, rhythm-oriented music, actually not rhythm, but temporal-oriented music. So his purpose was to do music that was multi-temporal. This means that the same piece of music was done in many tempos at the same time, and he was able to organize this in a very interesting way. We won't be able, unfortunately, we won't be able to listen to the music because we don't have much time, but let's hope that the examples that we play from the platform are enough to give you an idea. And, well, if you're interested, please listen to the music of Conlon Nancarrow, it's amazing. Okay, first, this is a presentation of a critical position and also an algorithmic position of the canons of Conlon Nancarrow. So first I will have to go through the context of this music. Well, Conlon Nancarrow was born in Texarkana, a small town in the south of the USA, in 1912. So he grew up in the Jim Crow era of the south of the US, and that will influence his later political positions that will be very important for this platform. Okay, he studied, he was going to study engineering, but he lacked the discipline, apparently, to study engineering, so he ended up studying music. That doesn't require discipline, apparently. He studied with Nicholas Lonimsky, Walter Piston, and Roger Sessions. These are like big names in North American modernist music. Well, he became a trumpet player, and he loved jazz, so he was in a big band. He was touring constantly in Europe and US, and well, he was quite politicized. He joined the Communist Party of the US, and well, this drove him to go to to come to Spain to fight in the Civil War with the Second Republic. So he fought with the Lincoln Brigade, that was part of the International Brigades. This was the American contingent that fought here. You can see his military history there. He was wounded in action. Well, quite an interesting life so far. Well, when the war was lost, he managed to escape to France and then took a ship back to the US. But the US was in a weird moment as well. He was persecuted by the McCarthyist governments since he was considered a socialist because he supported a socialist government and he fought, etc. No? So he was denied a passport, and well, he lack of options, and he felt threatened, so he decided to migrate, as many will do. He had two options, to go to Canada or Mexico. These were the legal options to migrate. So he decided to go to Mexico because Mexico at that moment had like a very interesting socialist welfare moment. And well, he came here, but he came here too late because that moment was closed already when he arrived to Mexico in 1940. And well, what happens after revolutions fail is that there's a weird fascistic moment. And well, Mexico at that moment was a sort of nationalistic, was leaning towards a very nationalistic mindset. So everything that sounded or looked foreign people were skeptic about it, to put it mildly. So he was excluded from the Mexican music community, so he was not able to continue working on whatever he wanted to work. He felt alone, I guess, I don't know. But anyway, he decided, well, he tried to compose scores, chamber music, but a Mexican clarinetist told him that his music sounded that he wrote it when he was drunk, so this discouraged him to work further on it. So he looked for options that did not require humans, and he found one in a book called New Musical Resources by Henry Cowell. He started to think of composing music only for player pianos, you know, like these pianolas, like these automatic piano players from like late 19th century. And well, that was it. From that moment onwards, he only composed for, well, not only, but mostly composed for piano players. And one of the main characteristics of the piano players is that you can do quite interesting things with rhythm and time. Okay, his first performance was in Mexico City. Then he was found by John Cage and Charles Americanian. And he was, later in the 80s, he was, as I say, there canonized by Ligeti. Ligeti wrote a letter to someone saying that Nancarrow was the best composer ever or something. And people started to acquire interest in the work of Conrad Nancarrow. So Mexico City became this sort of mecca where people came and just to talk to Nancarrow or to, well, to do some research about it, etc. So after his passing, well, there was a lot of interest in the 90s, most importantly the book of Kyle Gann about the work of Conrad Nancarrow. And after his passing, well, there was like a controversy of what to do with the archive of Nancarrow that included the pianolas, the scrolls that contain the compositions, and his library. His library is amazing. Well, what to do? The first option was to make his house a cultural center with the pianolas there displayed and with festivals, etc., sponsored by the Mexican government. But that, well, Mexican government was not interested, firstly. Secondly, there was a pressure from the Sacher Foundation to acquire those treasures for Western art. So, at this moment, the pianolas and everything was acquired by Sacher Stiftung. They were taken to Switzerland and they were locked and closed forever and rest in peace in a basement of a European tycoon. And well, what happens when the heritage of Mexican musicians, but because at this point, Conrad Nancarrow was Mexican, socialist Mexican musician. What happens when young artists from Mexico are denied from something that could be claimed as their heritage, that they won't have access anymore? What can we do to actually relate to this, that is part of the history, the cultural history of the city? No? This is a moment, this is the question that drives our research to design this platform. And well, what we found that we could do is to relate not to the work of Conrad Nancarrow, not to the thing itself, but to the ideas of Conrad Nancarrow. And as we know, ideas are algorithms, or yeah, something like that is in the Top Lab Manifesto. And well, we made a relationship. So live coding naturally fits with the ideas of Conrad Nancarrow, and this is where we are. So we did a platform that Diego will show you in a moment, but before that, well, we already use it, and in Mexico we try to do things collectively. So someone invited us to perform in the house of Nancarrow, and that is amazing because his house is very special. And well, we did this concert with the live coding community. Many members of this community are here. Marianne, Emilio, Rodrigo, Frank, etc. And well, it was a pretty cool experience. And we sort of tried to decanonize Nancarrow by playing some sort of weird multi-temporal techno there. And well, yeah, it was fun. And I will leave you now with Diego that will explain to you the interesting stuff.
So, well, first I will talk about a little bit about the structure of First I will talk about a little bit about the structure of the two classes that are implemented. The first one is called Can, and it's responsible for generating two types of canons, which are the convergence canon and the divergence canon. I will show them to you in a bit. And there are several helper methods that they're just useful to make it easier to do live coding, but they are not absolutely necessary. And these both main methods output a canon class, well, canon instance. And this canon instance has receives two messages that output data. One is the canon, which is the generated data structure, and then is data, which is just the preserved input. And it responds to the play, stop, resume, and pause methods, so it is able to interact with tasks or p-binds and everything that has this interface. And it also has a visualizer that is useful for pedagogical reasons. So, well, first I will show you like a simple melody, and then I will show you how it transforms. Okay, so in a convergence canon, we can do something with maybe 2 voices first. So as you can see, the melody is repeated, but it has been transposed both in time and pitch. There's a larger melody and there's a shorter one, which is the fastest. And they both have this point of convergence, which we can choose. And well, that's the point where both melodies are sounding the same sound event at the same time. We can, of course, play as many voices as we want. And, well, I can show you also the divergence method. Sorry that I'm not getting into the API, but it's like we have not much time. And this will generate a very different type of canon. I will show you. What is happening here is that we have all voices have the same duration, and they have different tempos that each one, like, each tempo is played at a different moment in each voice. So, but they all play the same tempos, and all tempos span the same amount of melodic time. So the tempos are interchanging. And well, one of the main aims of this library is to be composable, and what I mean by this is that it always takes data and returns data, and the side effects are delayed until the very last moment. And this is useful because it allows us to extend the library or to extend add new functionality, but also to integrate other tools like I don't know if you noticed, but we showed an image of Instrument, which is a library by Rodrigo Frank, and he just used the data structure to use the output of Nanc-in-a-Can and to put it into his library. So, well, we can, for example, use other methods instead of the ones that are provided by the library. Like, we provide can.melody, but we can use like our own custom method. Okay. We can also use the output to do something with it, and here we can concatenate 2 canons. So we have we will be listening to a canon played by a pianola and a canon played by a sinusoidal synthesizer. Well, the sinusoidal was a little bit soft. And we can also pass a function to a player key, which allows us to do something else with the canon and to use like a custom player. So here we will be playing. We'll just be printing the output, but we can do anything else. We can also, of course, call pause and resume and everything. And well, I can show you if we have time. No, we have no time. Okay. Well, thank you. I don't know if you have any questions.
Thank you. It was a very interesting presentation. I wanted to ask, or my question is, how do you use this in live coding performance? I asked this because from the examples you showed, it was, we waited almost to the end or we have to wait a certain amount of time to notice the different, I guess the canon by itself. So the different voices, how they were progressing. So yeah, how do you do that in live coding, or yeah, how do you use the library?
Hi, Luis. Yeah, tomorrow we're performing with the Nanc-in-a-Can, and you will see it by yourselves. Because of pedagogic reasons, we added a visualizer that we're using right now to show how does the canons work. But you don't actually need to use a visualizer, so you can just play with it. Both methods, divergence and converge, have a key that is called repeat. So it loops, and you can compile it as much as you want, and it won't stop playing. So yeah, it has a looper. You can live code with it. Something very particular that happens with Nanc-in-a-Can is that it slows down the programmers. You need to wait. You need to listen to the structure to develop a little bit so the platform makes sense. At least that has been my experience. So it not only proposes like a different temporal mindset, but it also promotes a sort of different way of live coding practice, live coding habits, to put it in a way. Maybe tomorrow we can clarify it in practice.
I guess continuing on this idea of slowing things down a little bit. Sorry, over here, Alejandro. Yeah. Do you think that we could see Conlan Nancaro working in the middle of the 20th century as a live coding pioneer?
Maybe a very, very, very slow coder. But yeah, I will say that there's a relationship, quite direct. I mean, he worked with algorithms, and well, I don't know. It's a very difficult question, because I think also the technology that he was using that didn't allow him to work like instantly was part of his creative output. I mean, he took 20 years to write. Well, he worked various of his pieces simultaneously, and he took like 20 years to finish one. He actually thought a lot about what he was doing. So I am not sure if I can say it has a liveness component that is like that natural, Conlan Nancaro, but I will say that there is a lot of common ideas and common practices between live coders and what Conlan Nancaro was proposing in the middle of the 20th century.
Thank you very much. So Nanc-in-a-Can created pieces that exist as player piano pieces that are, poked into paper that can be played. Have you ever tried live coding using his musical material or with his music?
Well, we coded the study 14 that is known as the canonic study. Well, one of the canonic series studies that is like the manifesto of Nancarrow, applied manifesto of Nancarrow that clarifies what a temporal canon is. It's like the objective of these studies, apparently. We coded it, like to put an example. Could you write the thing?
No, we can. Well, we just re-implemented the API, so that canon has not been adapted to it.
But in the future, you will be able to perform the study 14 in the platform, and it shows like it's an amazing way of reflecting about the work of Conlon Nancarrow, coding it. You realize that he takes little decisions, like, for example, if two voices are aligned accidentally, he sometimes like slightly twitches them so they don't, no? And you can see like nuanced details about it, and you get very clear ideas of how he worked doing that. But live coding with that, I guess it will be possible. The structure is there and the code is there, but we haven't thought of remixing Nancarrow, no.
Thank you, Alejandro and Diego. And we'll move right along to the last paper of this session with Sean Lawson and Jeremy Stewart, presenting on their performance we saw yesterday.
Yeah, we'll try audio. All right, you want to try it, or I'll send you something. Yeah. Do you have anything coming from the audio? Okay.
Probably muted in the back.
Yeah, I see it all. Okay.
All right. Oh, yeah.
Right. Okay. Everybody ready? It's post-lunch speaking there. All right, we will try to go slow because we know it's being translated. Also because I don't really understand it, and you do. So this is Jeremy. I'm Sean. We are both at Rensselaer Polytechnic Institute, which is upstate New York State. And this is about Cibo, our autonomous TidalCyles performer, which is a neural net system. If you were here yesterday, You would see that performance. We'll show you a short clip of that today. We'll give you some details, but not the other granular, nasty stuff. If you want to know that, ask Jeremy. Yeah. So, what is this thing? That's an excellent question. We'll try to... This is a pre-recorded sample, not from yesterday. Talk over it a little bit. On the right side is a text editor that's communicating with a Python process on the left side, which is speaking with a neural net trained system that's taking in title and spitting out title code. And now I'm done for a little bit, and you're up.
So how does this work? Yeah, that's a good question. The way that we approach this, the question of like how to make an autonomous machine learning driven title performer was instead of looking at it from, or instead of approaching it from a stance that starts from sound and listening as the starting point, we decided to look at the actual syntax of title code. This entire piece of software sort of focuses specifically on TidalCyles code, taking as input TidalCyles code and outputting TidalCyles code. And in its current form, it's not actually a listening agent in any sense. So at its most basic, we input some block of title code and expect it to output a different block of title code, which could be a slight modification of that or something totally different. You know, the point is input code block, output different code block. And the entire architecture is based off of this sequence-to-sequence encoder-decoder architecture that was first proposed in 2014 by these two research groups on these two papers here that was sort of simultaneously written about from two different perspectives. This sort of encoder-decoder approach sort of offers one solution to a problem when dealing with neural networks, which is the question of working with variable length inputs and outputs which may not be of the same size. And if you're dealing with a sort of network architecture that you have to tell it how big of an input or output to expect, it makes it kind of hard when you don't know how big an input or output might be until runtime. So for this, this sort of approach is used a lot for machine translation, like this example here on Google Translate, translating from English to Spanish. Sometimes, you know, the number of items in a given input may match the number of items in a given output, but frequently they don't. And it does this, actually, let's go to the next slide. No, let's wait. It does this in a sort of fancy, convenient way where it takes in an input of some unknown length. It could be 1 item or 20 or 30 items long, and it converts it into an internal encoding that is always of a fixed size. And then that's the encoder part of the network. And then the decoder part of the network takes that fixed size representation and just starts reading it back to produce output. And it just keeps reading it back until it reaches the end of sequence, which is a particular, it's denoted by a particular token. So we're going to go briefly through the sort of flow for how the software works. We have the text editor, which you saw up here on the right momentarily. And we're sort of taking that real TidalCyles code. It gets piped over OSC into another script that repackages it and tokenizes it into a format that's appropriate for our neural network. And then the third block here is the Cibo NN, which I'll talk about at most length. And then the post-processing at the end is to convert it back into something that the title interpreter actually knows what to do with, or like a human performer would know what it means. Okay, so the pre-processing first. Starting at the top there, that's like a recognizable, for anybody that works with TidalCyles, that's a recognizable title statement, playing the 808 kick sample, and the first two values are notes. It's a -1, that's an interesting choice. But that would be like something that like I might type and input into the title interpreter. In this case, that input is piped over to another process that tokenizes the entire thing, which is the second line that you see underneath that, where this input is separated into all unique token types and converted into integer values. Importantly, there's a couple of these token types, mainly integers, floats, and string values that actually have particular values attached to them. They're not merely a token type, or we decided not to merely represent them as a token, but they need both a token to denote that they are a float or an integer or a string, and then an attached value that describes what should go along with that. So those are actually separated into two separate things, the tokens line directly under the input, and then the values, which are the associated values. The start and the end are the SOS and EOS, are the start of sequence and end of sequence, and those are just appended and prepended to each token group before their input. So then the bottom line there, we have the actual sequence as its input into our Cibo agent. Okay. This is the rough one. Yeah. I'm going to give a brief overview of what's happening here, and all of the granular details are in the paper for how everything's functioning. The two most important parts here on the left-hand side are the encoder RNN and the decoder RNN, which function in that sequence-to-sequence encoder-decoder architecture. And everything else around that is sort of supportive of that architecture in this particular implementation for live coding. So that input sequence would have been that collection of tokens that I ended the last slide with, going into the encoder RNN. And that spits out two different things. There's the variable length output on the left, which is essentially the same length as the input token set is. And then the fixed length output, that's really the important piece here, that sort of represents the meaning of whatever just happened, and therefore it directs what would happen next. In a sequence-to-sequence encoder-decoder neural network architecture as it's described in the literature that was referenced on the previous slide, these two items would go into the decoder RNN, where the variable length would be used with an intention mechanism, which is a whole other thing that's discussed in the paper. And the fixed length tensor would be decoded and read back to produce a new output. Our addition here is the Cibo RNN over there on the right, which just functions to sort of alter or manipulate that fixed size representation on the inside, which is sort of retaining a hidden state throughout the course of the performance. And been thinking about this as like shading the input and output based on performance context, which could be initialized to a different state at the start of every performance or modified in different ways. So then that gets modified by that little chunk, decoder RNN, and we kick off the decoder RNN by telling it, here's a start of sequence, start reading back a sequence, and then just let it spit out new information until it gives us an end of sequence, or until it blows up, which hopefully doesn't happen very often, but produces interesting results when it does. And then some of these require values to be attached to them, either floats or ints or string values. So those are constructed through an additional process right there at the end. Post-processing. So our output might look like this line across the top, which doesn't mean very much to somebody who's just interested in live coding in Tidal. So first thing, strip away the start and end of sequence tokens, and then convert those values back to what they represent, which would be, they're sort of scaled or looked up in a dictionary that's held, and recompile that into a string through the process at the bottom of the line so that we get our next state back. That gets sent back to our text editor, and our text editor resubmits that new block to the Tidal interpreter, which also resubmits that new block back to the neural network architecture to produce another new output.
Fortunately, we're running short on time. So we don't have to know what it means. Well, maybe. I guess I have 2 minutes. We don't know what it means. Some things we thought about in the paper. We referenced Stephen Tanimoto and his paper, A Perspective on the Evolution of Live Programming. We're projecting maybe it hits level 5, which means that it's tactically predictive. We have questions about whether or not is the neural net actually thinking? Is it performing? I don't know. There's another interesting paper by Emma Cocker that she writes. It's titled Performing Thinking in Action, the Melete of Live Coding, where she talks about in a live coding performance, where is the thinking happening? And she's postulating that this happens as an active disclosure at the location of the cursor. Our cursor doesn't move. It could be true the neural net is not thinking. So we don't really know the answer for this. Is it over here? In the neural nets, in this output, is this the thinking in action? We're only good at asking questions, not answering them. And then there's the sort of the larger overarching question about this, which is it any good? For those who were here and listened to it yesterday, heard the 1-minute sample today, is it good? I don't know. I don't know. I do graphics. I can't evaluate. But we did find a really interesting quote by Andrew Brown. He was talking about his own work, and he's quoting someone else by Auslander, which he says, this is specifically in context about having a lot of technology in your performance. Like, why do you have a lot of technology? Is it purposeful? Do you need this? Clearly, this neural net system has an incredible amount of technology. We didn't talk about any of the training overhead, any of the captured data that we used, captured performance to do the training. It's in the paper. But ultimately, what he's saying is that this show us your screens feature of live coding practice assists to reveal the process and virtuosity of the performer, which in our case, I don't know who that is. Underscoring Auslander's point about performance with technology, that what counts ultimately is the audience perception not the actual degree of difficulty, which then I don't know. We didn't do anything, really. It performed, but the question then again is, if you had heard it, was it any good? And then you can tell us yes or no, or I don't know, which is our answer. We don't know. So that puts us at 14 minutes and 58, 59, 15 minutes exactly. So I think we're done, yeah? We acknowledge NVIDIA for giving us a graphics card to help train our system. Thank you. And now we're done. Oh, I don't know. It's okay. We don't have to.
I was just a bit confused about where if you could go back to the diagram of how the neural net works. Yeah, so where you have the variable length output and Cibo RNN both going into the decoder RNN, like, I just didn't understand that step. Like, what is the variable length output contributing?
I'm going to try to do this justice, explaining it quickly, because we fought a lot about how to explain it succinctly. The variable length output is used by the decoder in a module that it's called an attention module that permits the decoder to basically apply weights to portions of the input sequence as it's considering what to output next. But in sort of like a vanilla encoder-decoder architecture, that attention module isn't necessary for the system to work, so that variable length output that's going into the decoder isn't necessary in that case. So this is sort of like a slight augmentation to that that just sort of further makes use of the original input sequence.
And what might be important in that sequence?
If you were, like, let's say, I would be speculating here, but to decide what kind of token might come next, it might be more important to look at a given 3 tokens from the input rather than the entire input, which might be 30 items long or something like that. So it would just provide a mechanism to sort of focus the output creation, generation.
Thank you.
Yep.
I just don't get if this process is deterministic or random or chaotic. Does the same input produce the same output every time or not? No.
No, it isn't. And this, I mean, in the sense of like a machine translation using like spoken language, you'd want it to be the same every time. So here, through mixing in this sort of like additional hidden state that we're initializing in a pseudo-random way at every performance, it sort of is more unpredictable, non-deterministic in a way.
Okay. Yeah. Great, thanks.
I assume that the network was trained on just static pieces of code. So I'm wondering if you trained it on a recorded performance, so including time and how code moved from sort of over the duration of the performance, would the network be able to sort of take a step back and figure out when to change stuff in addition to what to change?
Well, I mean, it's halfway there. It is trained on performance capture, so part of what we didn't talk about here, which I think is in the paper maybe, is that the methodology by which it's trained is by using text capture of performance with time data. At the time of writing the paper a few months ago, we hadn't implemented a timing mechanism between executions on that information, but the recorded information that we have from pretty much all of your, maybe a half dozen or a dozen different performances that we trained it on, does have timing information in it of when did this execution happen from the beginning of the performance and what is the delta time or the time passage from a previous execution to this execution. So we have the information there, but haven't yet shoved it into the system or added another thing on to Frankenstein it more. But I think we're interested in using that information, yeah.
Hi, very interesting presentation, thank you. I just wanted to ask, what's the future work that you're going to do in terms of presentations or performances and also development of the artificial intelligence or the piece?
Do you want me to just, well, so right now, we've already tried something else and it failed hard. So we have to rethink a project that we already tried. I think we are planning on doing more with it. One thought that we've had, has anyone done work with computer vision? Tracking faces? Anyone knows it works really, really, really well with Caucasian and Asian and fails with pretty much everybody else? So that trained neural net system has an implicit bias built into it based on those who programmed it. And so our system right now has an implicit bias of 1. So we want to find out, and our tools are a little rough right now to abuse people with them. So once we can have them suitable enough, we want to have more people using Tidal to give to us, if they're willing to, send us their recordings so we can try to expand the system and see if there's differences between different types of performers, because lots of people use tidal cycles in many different ways, and so we want to see, is there a generalized way, is there individualization? You know, there's a lot of areas we'd like to explore, and we're at step 1 and have to grow it. I don't know, do you have more you want to add to that?
I mean, right now, it's functioning as like a solo performer agent, but really the goal from the beginning was to create some sort of like collaborative agent to perform with, whether that be in just collaborative in Tidal or collaborative across different languages.
Oh. Thank you so much. Thank you to all the presenters in this session, and thank you for letting me be strict with time, because now we have a tiny break before the workshops start at 4. And thank you to everyone for their great questions. All right, enjoy the next workshop session.